So what does it really take to build a high-performance electric motor? And I'm not talking about the little one buzzing away in your desk fan. We're talking about a motor so powerful it completely changes the game. This is the story of that journey, from a simple piece of metal to something with just roaring power.
Yeah, you heard that right. That is the actual claim for the biggest motors they make at this factory. We're talking an absolutely insane amount of power, and it's all packed into a motor that weighs just 16 kilograms. That power-to-weight ratio it's almost hard to believe.
Well, the answer is this amazing mix of brute force, incredible, mind-boggling precision, and what one of the engineers there literally calls black magic. So let's dive in and follow this process step by step and see how they turn inert metal into an absolute powerhouse.
Okay, so our journey actually starts outside the main factory, at a totally specialized facility. Because you see, before you can even think about building the motor itself, you have to create its most critical part, the permanent magnets.
That's right, these super powerful magnets, they start their life as these, well, kind of boring non-magnetic blocks. So the very first step is all about mechanics. They take these blocks and slice and shape them into these perfectly curved segments that are going to fit exactly inside the motor's casing. So here's the whole transformation. After they're rough cut, they get ground down to the perfect size. Then they get a protective 3-layer coating. And then, this is the magic part. They're put inside a huge electromagnet and bam, they get blasted with 2 kilovolts of electricity. In a single instant, that jolt aligns all the magnetic poles and it creates a super strong, permanent magnet. Just like that. I mean, the before and after here is just night and day. It goes from this rough, useless piece of metal to a super precise, coated, and incredibly powerful magnetic component. And that nickel-copper-nickel coating? That's super important for durability. But it's that final blast of energy that really brings it to life.
2 kilovolts. That's the secret sauce. Just pure electrical force, turning a chunk of metal into the heart of a beast.
All right, so we've got our magnets. Now we need the other key piece of the puzzle, the stator. This is the stationary heart of the motor, the core that the magnetic rotor is going to spin around. So the stator is basically this laminated core that holds all the copper windings. The rotor, with those powerful magnets we just saw being made, is what spins around it. And making this core, well, that's a whole other engineering marvel. Okay, this is so clever. Instead of stamping out hundreds of individual plates and then having to painstakingly stack and laminate them, these machines do it all in one go. A continuous roll of thin steel just feeds into one end and a fully formed stator core pops out the other. It's incredible. And you can totally see why an engineer would call this black magic. The tool that makes this happen, it's called a progressive stamping die, is just unbelievably complex. With every single punch, it's cutting, shaping, and advancing the steel just right until a perfectly stacked stator core is born. Okay, now we're heading to the main factory. This is where all these amazing, precisely manufactured parts, the magnets, the stators, the machine-carved casings, all get brought together for the final assembly. Now this part is fascinating. When it comes to winding the copper coils onto the stator, there's a huge difference. For the simpler motors, a machine can crank out about 12 an hour. But for the really powerful high-end models, the ones with these thick bundles of over 36 copper strands, it has to be done completely by hand. It's a perfect example of where human skill is still just irreplaceable. And the finishing touches, they're all about getting flawless performance. The copper wire tips get dipped into molten solder, which instantly burns away the enamel coating, so you get a perfect electrical connection. The windings are glued down with extreme care to stop any vibration. And then, those powerful magnets we saw get placed by hand into the rotor, making sure to alternate north and south poles perfectly. This number just blows my mind. The gap between the part that spins, the rotor, and the part that stays still, the stator, is just 0.03 millimeters. We're talking thinner than a human hair. And that is why gluing the windings down is so critical. If there's even a little too much glue, any tiny imperfection, the two parts could touch, and the whole motor would just seize up and fail. It is a game of microns. So after all that precision, all that careful assembly, there's really only one thing left to do. Plug it in and find out what it's really made of. every single motor that comes out of this factory gets put through some serious testing on a dynamometer.
So this dyno test, it's like a complete physical for the motor. It checks all the vital signs. Does it hit the RPM it's supposed to? Is it drawing the right amount of current? Is it running smooth and quiet? It's not just about pass or fail. It's a full performance report.
And here we go. The test on this big drone motor is starting. Now, what you want to watch is how the input power, which we measure in watts, gets turned into output force, which we measure in kilograms of thrust. You can see the power draw quickly ramps up. It's already at 5,000 watts, but we are just getting warmed up.
It just keeps climbing higher and higher. Now it's pushing past 7,000 watts. This is it. This is where all that precision manufacturing really pays off.
And there's the payoff. All of that electrical power is converted into an incredible 130 kilograms of pure raw thrust. To put that in perspective, that is more than enough force to lift a person clean off the ground. All of a sudden, that claim about 8 of these lifting a car, it doesn't seem quite so far-fetched anymore, does it? So what's the real secret ingredient that makes all this possible? Well, it's not just one factory. It's the entire ecosystem. It's just like this quote says. The real magic is that you have specialized factories for plating, for anodizing, for CNC machining, for raw materials, all within a few minutes' drive. That whole network is what lets them build things this amazing, this fast. So from a simple block of metal to 130 kilograms of thrust, the journey of this motor is just this hidden world of unbelievable skill and power. It really makes you wonder, doesn't it? What other things that we see and use every single day are hiding a story this incredible, just waiting to be discovered?